Hi students, in this video we're going to discuss about the coordinate system. I mean basically coordinate geometry. Nana. So in coordinate geometry, first of all you should know what is a Cartesian coordinate system. We are going to discuss about the coordinate system, which is a combination of x-axis and y-axis, where all the point of intersection of this x and y-axis is known as origin, right? That is denoted by capital O, and which is 0 comma 0, and here it's going to be all positive numbers, and here it is going to be negative numbers, and here above x-axis all positive numbers, and here it is negative numbers, right? Here you can see that x and y are always positive. Here x and y is positive, and here you can see that x is negative and y is positive. Here both x negative and y also negative, and here x is positive and y is negative. So based on the given point we can decide like where it will be. Like for example, if they given some 1 comma 2, it lies, both are same now, so it lies in first quadrant. Like for example, minus 2 comma minus 3, then it lies in what, on both negative, means it's going to be quadrant 3. Quadrant 3, like this. Based on the given point, we can plot where the point will be, right? And here where, when you are writing this x comma y, this x coordinate, this is called as x coordinate, and which is also called as abscissa. The other name for this is abscissa. And y is y coordinate, and which is also called as ordinate. So we should remember these names, Sana. So in the questions, definitely these names are using to describe about x coordinate and y coordinate, right? This is about the basic Cartesian coordinate system. Now distance formula and its applications. Already you know the distance formula actually from your grade 10, but we'll just roughly recall like what is the distance formula. Let us take a point here, some x1 comma y1, right? And the other point somewhere here, let us say some x2 comma y2. Now if you take the point here which is x1, and the point here which is y1, and this one which is x2, and this is y2, and now the distance between this we are going to discuss, right students? Now what will be the point on this one at this point, so which is x2 comma y1, right? Because here x2, x coordinate is x2 and y coordinate is y1. Now you can see that if you take these vertices as some a b c, here you have a right angle triangle, right students? So what is the distance here now? AP distance, so this x2 and x1. So that means if you write x2 minus x1, that is what the AP distance. Next, this BC distance, if you want to find, you can say it's y2 and this is y1. So in between that we need, which is y2 minus y1. And you can see that ABC is forming a right angle triangle. So we can use the Pythagoras theorem, and we can say that okay, AC square is equals to what, AB square plus BC square. That means from this we can say AC is equals to under root AB square, which is x2 minus x1 whole square, next plus y2 minus y1 whole square, right students? So this is what the distance between two points. For example, if I want to find out the distance between some 2 comma 3 and minus 1 comma minus 2, then the distance between them is going to be x2 minus, like let us say the given points are x1 y1 and this is x2 y2. So minus 1 minus 2 whole square plus minus 2 minus 3 whole square, like this. Now it's going to be minus 3 whole square is 9 and minus 5 whole square is 25. So square root of 34 is the distance between the 2 points, the given points. What about distance between origins, sir? So distance from origin. Now to discuss distance from origin, let us say the point is some a comma b and origin is some 0 comma 0. I don't know distance between them. Directly we can say that what, on a root over a minus 0 whole square, directly a square, b minus 0 whole square, so which is b square. So directly we can say that it is root over a square plus b square. So whatever the point you want, the distance from the given point, then simply squaring for the x coordinate and y coordinate and adding it, then apply square root. Simple, right students? Yeah, next. Okay, let us we'll just discuss one little bit difficult question. Like we know the distance now, so we'll see. So PQ they are asking us to find. So A cos beta minus A cos alpha whole square, because x2 minus x1 whole square. This is x1 y1 and this is x2 y2 plus y2 minus y1 whole square. So A sin beta minus A sin alpha whole square. Right. Here you can see anyway, we can write this as A minus B whole square na? So A square plus B square minus 2AB, right? Plus here also A square plus B square minus 2AB under root of this. Now you can see from every term you can take A square common, then cos square beta sin square beta value is 1, and cos square alpha sin square alpha value is also 1, and here I can take minus 2 also common. Then I have cos alpha cos beta minus I took common, so sin alpha sin beta. So this is what we have. Right, students? Now we can see it's A square, and here also 2 also common, so 2A square of 1 minus cos of alpha minus beta. Yeah. What about this Nana? 1 minus cos A. So it is like 1 minus cos A. We discussed this in a trigonometric video, Nana. So those who have a trigonometric idea, they can understand what I'm saying here. So 1 minus cos A is what the formula 2 sine square A by 2. So 2 into A square into 2 sine square of alpha minus beta by 2. Here A is alpha minus beta, so under root. So what is the answer now? So 2 to 4, that means 2. So root A square is A, and sine square means sine of alpha minus beta by 2. Modulus for that, because it's going to be plus or minus. So 2A sine of alpha minus beta by 2 will be the answer. So third option, you can see that. Right? This is how we can use the combination of trigonometry and straight line, I mean coordinate geometry, in a single question. Right, students? Next, section formula. Section formula, here we are going to discuss two formulas, like internal division. Similarly, and we know that it's external division. So we are going to discuss both. So internal division means, like for example, they will give you a point P, and P will divide AB in the ratio of, like let us say this is some x1 comma y1, and this is some x2 comma y2. So this m is to n ratio. Simply now what we can write, Nana, PA is to PB. I mean, like I want to find out P point here. The P point is equals to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. That is the basic. So here m x2 and n x1. Next m y2 n y1, like that, like cross multiplication. Like that you can remember. And of course, to prove this, definitely we can just simply draw the 2 points, like just like how we did the distance formula proof. The same way you can just represent them on a coordinate system. Then we will use similarity of triangles concept, no? But directly, since you already know it's from grade 10, directly I'm just writing it. And what about external division, Nana? That means the P is dividing externally, Nana. P is dividing A and B externally, like this, m ratio, and here it is n ratio, like this. Then the formula for P is going to be same thing, but in between we have minus mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus. So this is the formula for external division now. So right, students? So now just let us do some questions. Let us say, for example, find P which is dividing AB in 1:2 ratio. So where A is some 1 comma 2 and B is -1 comma 3, something like this they given. So you can see this is M, this is N, and this is going to be x1 y1 and this is going to be x2 y2. I'll do both here, internal external. We'll see. For example, internal I want to do. So internal division. So mx2 means 1 into -1 plus n x1. Sorry, x1 is 1 there. By m plus n, that means 1 plus 2, comma my2 plus ny1 is divided by 1 plus 2. So it's going to be 2 minus 1, so 1 by 3 and 7 by 3. This is the internal division. So what about external? So external means, actually when they have given ratio, if they don't mention external, they will give you a negative sign. And anyway, we are going to write it here. So like for example, same thing you will write, but the only difference is in between minus. So 1 into -1 minus 2 into 1 by 1 minus 2, 1 into 3 minus 2 into 2 by 1 minus 2. So what will get here? Minus 3 by -1 comma -1 by -1. So which is 3 comma 1 is the external division point. So remember whenever they mention external, of course if they mention internally, if they given the ratio is positive, the ratio will be positive in internal division, Nana. And in external division it is always negative, Nana. Okay, right. But sometimes the questions will be like this: determine the ratio in which the line divides the line segment. Like for example, what they are saying, Nana, so there is a line here, a 3 comma -1 and 8 comma 9. So the line segment joining by these 2 points, and another line is there here, which is y minus x plus 2, is dividing what ratio? That is what they're asking. That means this point divides division. Of course, indirectly they are asking us to find the point which divides the given line A and B in some ratio. We don't know that. So since we don't know the ratio, just assume the ratio as something like assume the ratio as some k is to 1, something like this. This is m, this is n, and this is going to be what, x1 y1, and this is x2 y2. Simply what we can do here, we are finding this point P. So P is equals to, so m x2 plus n x1 by m plus n, comma m y2 plus n y1, and x1 here it is did a mistake here, x1 is 3, yeah, so by m plus n, right. So P is equals to, then what we have now, 8k plus 3 by k plus 1, comma 9k minus 1 by k plus 1. This is the point we have. Now we know that this is the P point which will be in this, on this line, Nana. Right, so this is x and this is y, so simply substitute that x and y, because we know that the P is a point on this line. On this line the point we have, Nana, so substitute that y and x there. So what we get here, y is 9k minus 1 by k plus 1. So this is on y minus x plus 2 equal to 0, Nana. So substituting there, so minus x is 8k plus 3 by k plus 1, right. So now plus 2, that is equals to 0. Now if you simplify, the LCM is k plus 1, you can see that. So 9k minus 8k is k, minus 1 minus 3 is minus 4, plus 2k plus 2 is equals to 0. So we have 3k minus 2 is equals to 0, right? Because if you move this to the other side, 0 minus 4 plus 2 is minus 2. So k is equals to what, Nana? 2 by 3. So if I substitute here, 2 by 3 is to 1, which is nothing but 2 is to 3 is the answer. Okay. Okay, so this is how we can discuss the questions on this section formula. Maybe they will give you about internal division or external division. Sometimes they won't give you the ratio. They will ask us to find. Of course, if the given point directly we can equate here and we can do. And if the given point, if they're talking about a line division, means this is how we can do now. Okay. Yeah. Next, point of concurrence, which is very important point, like respectively the for all the competitive examinations. All point of concurrence means like two or more points meeting at a single point is called as what, Nana? Point of concurrence. Okay. In this point of concurrence, actually before going to discuss about this centroid, orthocenter and all, you should know the meaning of first median. You should know, Nana, what is the median? The line segment drawn from the vertex to its opposite side, like vertex of a triangle to its opposite side, which is dividing into two equal parts, is called as median. Which is dividing it into two equal parts is called as median. Okay, once again I am saying it may be, sometimes it may be perpendicular, but we will draw from the vertex to opposite side, that will divide it into two equal parts. So next you should have an idea about altitude. Altitude. So altitude means here the line joining from the, like drawing from the vertex to its opposite side and it's perpendicular to the opposite side. That is called as altitude. Of course, median is dividing the opposite side into two equal parts, and altitude is perpendicular to so opposite side. Okay. So next we should discuss about perpendicular bisector. Perpendicular bisector. So the combination of both median and altitude, of course, it may or may not be from the vertex now. May or may not be from the vertex. It can be from anywhere, but it is perpendicular to opposite side and dividing it into two equal parts. That is called as perpendicular bisector. Okay. So next we have angle bisector. So name only there. Angle bisector means which is dividing the respective angle into two equal parts. This angle, both are equal. If the angle bisector divides that angle into two equal parts, this is angle bisector. Now you should know these four definitions. Median, which is drawn from the the vertex to opposite side and dividing the opposite side into two equal parts. Dividing the opposite side into two equal parts. And altitude is drawn from the vertex to its opposite side and perpendicular to the opposite side. Right. Next, perpendicular bisector means it may or may not be from the vertex, but it should divide the opposite side into two equal parts and perpendicular to it. That is perpendicular bisector. Now, angle bisector is what, Nana? Dividing the angle into two equal parts. These are the important points that you should know before going to discuss about point of concurrence. So now coming back to the point of concurrence, the first point of concurrence that we are going to discuss is centroid. Centroid is point of concurrence of medians of a triangle. Like for example, if you take a triangle like this, triangle ABC, this triangle ABC will draw the median from the A to opposite side and B to its opposite side and C to its opposite side. Definitely in a triangle, if you draw all the medians will meet at a point. That point of concurrence is called as centroid, denoted by G. Denoted by G. And if A is x1 comma y1 and B is x2 comma y2 and C is x3 comma y3, you can see it is a midpoint. What is a midpoint formula? X1 plus x2 by 2 comma y1 plus y2 by 2 na, so it means x2 plus x3 by 2 and y2 plus y3 by 2. Now the centroid divides the median in the ratio of 2:1. That is also an important point. Centroid divides the median in the ratio of 2:1. So by using that ratio on this point and here, you can find out the centroid formula. Actually, the derivation is not required. The formula directly you can remember, x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3 is the centroid formula. If they given three vertices like some 1 comma 1 minus 2 comma 3 and 3 comma 4, then simply substitute there and you get the centroid formula. 1 minus 2 plus 3, right? X coordinates by 3 and some of the y coordinates also by 3. So what will get here? 2 by 3 and next 8 by 3 is the centroid of the triangle formed by these points. Right, students? Yeah. So next. So look at the example here. Two vertices of a triangle are 1 comma 4 and 3 comma 1. Let us take these as x1 y1 and this is x2 y2. If the centroid of the triangle is origin, so they already given centroid which is origin. So third vertex we need to find. So what is x3 and y3, right? So what is the centroid formula, Nana? So centroid G is equals to, so x1 plus x2 plus x3 by 3. So y1 plus y2 plus y3 by 3. So substitute. So this is anyway 0 comma 0. X1 is 1, x2 is 3, Nana, you can see it here, and x3 we are going to find. So by 3. And y1 is 4, y2 is 1, and y3 is, that is what we are going to find. So by 3. Now simply, since both are equal, so equate it. So you can write x3 plus 4 by 3 equals to 0, and y3 plus 5 is by 3 is equals to 0. So x3 plus 4 equals to 0, then x3 is equals to minus 4, and here also y3 is equals to minus 5. This is the third vertex of the given information. Right? Simply we are equating now because this point is equals to this, means we can equate the x coordinate and we can equate the y coordinates. Right, students? Next, incenter. Incenter is the point of intersection of internal bisectors, internal angle bisectors. So we discussed about it now. So angle bisectors. So A, B, C. And if you just simply draw the angle bisector of A, an angle bisector of B, an angle bisector of C, all those bisectors will meet at a point. That is called as incenter. That is called as incenter. And to find out the incenter, so if the given x1 comma y1, 3 vertices, x2 comma y2 and x3 comma y3, and the side opposite to capital A is small a, which is distance between B and C. Distance between A and C is small b, and distance between A and B is small c. Then the formula is going to be A x1 plus B x2 plus C x3 by A plus B plus C. Next, A y1 plus B y2 plus C y3 by A plus B plus C is going to be the incenter of the triangle. Directly you can remember this formula, which is incenter of the given thing. And here of course the incenter, if you just draw the circle with the radius from the incenter capital I to the side, that distance is always same now. Okay, so here I to this side, this, and I to this side, and I to this side is always same. That is also called as in radius, right? Okay. Next, circumcenter. Circumcenter means the point of concurrence of perpendicular bisectors of the sides of a triangle. So if you take a triangle, whatever the triangle you take, Nana, so first of all you should take the midpoint, and through that we will draw a perpendicular bisector, and here it is going to be this, like this. Okay, and now this is how it is going to be. So you can see it is may or may not be from the vertex, but you can see that all three are going to be meet at a point. That point is called as circumcenter. So circumcenter is always at equidistance from the vertices of the triangle, Nana. Okay, so if you just draw a triangle with that radius, that is called as circumcircle also, and the radius is called as circumradius. Whatever the distance is from, like for example, if it is S, this is A and this is B and this is C, so SA is equals to SB is equal to SC, and that is denoted by capital R, and which is known as circumradius. Okay, right, students. Now, so in right angle triangle, if you discuss the circumcenter and right angle triangle, so just we'll draw a right angle triangle and we'll see where you will get. Here, for example, this side we should draw a perpendicular bisector. This side also we should draw a perpendicular bisector, and this side also we should draw a perpendicular bisector. You can see that all will meet at midpoint. So in right angle triangle, the circumcenter is at what, Nana? Midpoint of hypotenuse. Midpoint of hypotenuse. So which is very, very important. So which is going to be useful while you're solving the questions. Okay, students. Next, orthocenter. So orthocenter means perpendiculars drawn from the vertices to its opposite side. So if you take any right angle, any triangle, any triangle. So for example, from this to this, a right angle perpendicular, and you can see on this one, it's perpendicular, and here. So if you extend something, definitely all these three will meet at a point. So the meeting point, the point of concurrence of the perpendiculars drawn from the vertices to its opposite side of a triangle is called as orthocenter and denoted by capital O. Right? So in a right angle triangle, again here also that point is important. In right angle triangle, you can see the orthocenter position here. So orthocenter, like C to B orthocenter, I mean perpendicular. A to B perpendicular here only, and B to C here and here. That means and in right angle triangle, the position of orthocenter at the vertex of right angle, at vertex of right angle, because from C to BA meeting at B, A to BC meeting at B, from B to C, yes, it's anyway starting from B. So the meeting point, the point of concurrence is going to be at B, which is at a right angle. Okay, so that is how we can find out the orthocenter position, right? Now, just there are a few points that we have to remember. So, if the triangle is equilateral, in equilateral triangle, all those, like whatever the point we discussed here, all those will meet at the same point. All are going to coincide, because the median will act like a perpendicular bisector also, perpendicular also, an angular bisector also. So, the centroid, incenter, orthocenter, circumcenter coincides definitely, because all will be at same point. And orthocenter, centroid and circumcenter are always collinear, are always going to be lying on the same line, and centroid divides the orthocenter and circumcenter in the ratio of 1:2:1. Always remember that point. And coming to an isosceles triangle, in an isosceles triangle, centroid, orthocenter, incenter, circumcenter lie on the same line. Yeah, definitely. So these are the points which we need to remember to solve the questions from this coordinate system. Right, students? Look at this question. The orthocenter of having vertices at 1, 1. Next, let us draw a triangle. So 1, 3, 1 and 3. You can see here 1, 1. Next 3, 1 will be here, and 1, 3 will be here. And if you join, you can see that you will get a right angle triangle. So just now we discussed the orthocenter position in a right angle triangle is at vertex of a right angle, which is 1, 1. So sometimes simply by drawing the figure you will get, and of course since it's a simple thing, directly by looking at this you can understand. But if you want to find out the orthocenter also, you can check whether the given triangle is right angle triangle or not. If it is right angle triangle, definitely we can check. How to check it is right angle triangle? Hypotenuse square is equal to side square plus side square. Based on that you can discuss. Sir, if not right angle triangle, then how to find? That we are going to discuss in straight line, because there we are going to discuss about the line, how to find the line and all. There we are going to discuss about that point. But now if it is right angle triangle, simply it is at the vertex. What about other things? So you didn't discuss any formula like centroid or incenter. So this orthocenter formula is very weak, and no way we are not going to use that formula. We are going to use this condition, or we are going to find by using the straight lines concept. There you will get clarity like how to find the orthocenter if it is not a right angle triangle. Okay. Now, see 5 by 2 comma 3 is the centroid of a triangle and its two vertices are 0 comma 1 2 comma 3. Then find its third vertex. We already did a question. So let us say that this is 5 by 2 comma 3 na? It is equals to centroid. What is the centroid? So 0 plus 2 plus a, third vertex, let us say that is a by 3, and x1 y1 y2, so y1 plus 3 and y3 let us say it is b by 3, and compare. So 5 by 2 is equals to a plus 2 by 3. Next 4 plus b by 3 is equals to 3. So just cross multiplication. So 15 is equals to 3a plus 6. So 3a is equals to 9. So a is equals to 3. And b plus 4 is equals to 9. So b is equals to 5. So you can see the third vertex is 3 comma 5. Right, you have got the third vertex. So from that, just by drawing the triangle, you can get what is the circumcenter, circumradius, and orthocenter. Right, students. Now area of a triangle. So area of a triangle means, so let us say A is some x1 comma y1, and B is some x2 comma y2, and C is some x3 comma y3. Then how to find the area of triangle, Nana? The formula we have actually. So half into simply x1, just follow the pattern, x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. We are going to follow the pattern here. So what is the pattern? 1 2 3, x terms are going to be in outside and y are going to be inside, and you can see 1 2 3 1 2 3. So 1 2 3 first, then we'll start with 2, then after 2 we'll get 3 2 3 1, then 3 1 2. Like that you can remember, you can find out the value of that also. And in matrices way also they will write so half into determinant of x1 x2 x3 and y1 y2 y3, and all these are 1 1 1, that is equals to 0. In that way also you can do it. Okay, for example, okay, before going to do this question, we'll do a small example. Like for example, I want to find out area of triangle of 1 comma 2 minus 1 comma minus 3 and 2 comma minus 3. Let us take this. So what is the area of triangle? And delta is equals to half into, so this is x1 y1 and this is x2 y2 and this is x3 and y3. So x1 into y2 minus y3, right, students, plus x2 into y3 minus y1 plus x3 into y1 minus y2. Like this we can find out. So now half into this is 0, minus 1 into minus 5 is 5, 2 into 5 is 10. So 15 by 2 square units is the area of the triangle. In that way we can find. Right, that is a basic example to find out area of triangle. Next, look at the question they given. The point A divides the join of the point minus 5 comma 1 and 3 comma 5 in the ratio k is to 1, and coordinates of points B and C are 1 comma 5 and 7 is to respectively find the area of triangle. That means simply, so A divides the join in the ratio k is to 1 they given. Okay, so first what we will do here, we'll try to find out the coordinates of A in terms of k. Then we'll use the area of the triangle with that A and with the B and C they given. That is equals to what, Nana? 2 they given. The given area is 2. So to find A, so this is K is M and N is 1. This is X1, Y1 and this is X2, Y2. So now K by means MX2, that means 3K plus nx1 which is minus 5 into 1 is divided by k plus 2. Next m y2 which is 5 plus n y1 which is 1 is divided by k plus 1. So what is the k coordinate? What are the k coordinates here? 3k minus 5 by k plus 1, 5k plus 1 by k plus 1. Now a, b and c are given. Use the area of the triangle formula and equate it to 2, then you'll get k. That's it, right? So you just try that on your own yourself. Okay, so this that's all about in this video. So in the next class, means in the next video, I will discuss about locus and transformation of axis. Okay, thank you so much.